To live is to take in information from the world and the body's tissues to make decisions and to send back information and orders to the body's tissue. This happens thanks to your body's nervous system. The central nervous system contains this brain and the spinal cord. Now, the brain that serves as the center of your nervous system is your brain. I like to call it the boss. The brain enables our humanity, our thinking, feeling, and acting. Your brain only accounts for about 2% of your body weight, but it uses about 20% of your energy. A grain of sand-sized speck of your brain contains about 100,000 neurons and 1 billion synapses. The brain's neurons cluster into groups called neural networks, much as people cluster into cities rather than spreading themselves evenly across the nation. Neurons form networks with close neighbors by means of short, fast connections. And guess what? Learning to play the guitar and speak in a foreign language and even solving a math problem, when doing this strengthens those connections. All those things are good for your brain. So the spinal cord, this is the other part of the central nervous system. It is the long tubular bundle of nervous tissue that connects the brain to the nerves and the rest of the body. It's a two-way highway connected to the brain and the peripheral nervous system. Some fibers in the spinal cord carry incoming information from your senses to your brain, while the others carry outgoing motor control information to your body parts from your brain. Now, what happens when people suffer damage to the top of their spinal cord? Their brain is truly out of touch with their body. They lose all sensation and voluntary movement in the body regions that connect to the spinal cord below its injury. So to produce physical pain or pleasure, the sensory information must reach the brain. If there's a disconnect in the spinal cord, that information cannot get to the brain. Anything below that injury will not be sensed. So now we have the peripheral nervous system. We have the two branches of the nervous system, the central nervous system and the peripheral nervous system. So your peripheral nervous system, it gathers information from other body parts and transmits central nervous system decisions to the rest of your body. Okay, so it links the central nervous system with the body's sense organs, muscles, and glands. All right, so it has two parts. It has the somatic and the automatic. So first, let's talk about the somatic nervous system. This is the part of the peripheral nervous system associated with the voluntary control of the body movements. Okay, so it the monitors sensory input and triggers motor output. It controls skeletal muscles. So it's associated with this voluntary control of bodily movements. The autonomic nervous system, however, this one regulates processes such as breathing, heartbeat, and other organ functions. It works automatically. So let's say it's like an automatic pilot. This system may be consciously piloted. This system may be consciously overridden, but it usually operates on its own automatically, with things like our digestive system and, like I said, the internal organs, heartbeat, these things. Okay, so now let's go to, we have also other branches in our autonomic nervous system as well. We have two branches of it. So let's go over these. We have the sympathetic division of our autonomic nervous system. Now, this division is the one that arouses the body, mobilizing its energy in stressful situations. If something alarms or challenges you, for example, like giving a speech or a presentation, your sympathetic nervous system will arouse you and make you more alert, energetic, and ready for action. It does this by increasing your heartbeat, your blood pressure, and blood sugar level. It will also slow your digestion and cool you with sweat. You'll start sweating with the sympathetic nervous system. So then we also have the parasympathetic division. So this is the division that calms the body, conserving its energy. When the stress dies down, so if we use our earlier example, we would say when the speech is over, your parasympathetic nervous system will calm you. It will conserve our energy as it decreases the heartbeat, lowers blood sugar, and things like this. In everyday situations, the parasympathetic and sympathetic divisions work together to keep our internal state steady. Okay, so here is a picture of the sympathetic nervous system and the different parts of the body and what it does. When we are stressed out or excited, it does things like it makes us so we breathe a lot more, it relaxes our bronchi, it stimulates our salivation, our pupils dilate, our stomach stops working as quickly. And then we have our parasympathetic division that kind of does the opposite of our sympathetic nervous system. It tries to calm us back down. All right, so our nerves. Our nerves are bundled axons that form neural cables connecting the central nervous system with the muscles, glands, and sense organs. So, for example, your optic nerve, it's a bundle of millions of axons that are into a single cable that carry the messages from each eye to your brain, so that your brain can interpret and send messages as to what you're seeing. Okay, so this information travels through the neurons, and there are 3 different kinds of neurons, basic types of neurons that we're going to talk about. There are sensory neurons, motor neurons, and interneurons. So sensory neurons, they carry outgoing information from the central nervous system to the muscles and glands. They carry incoming message from the sensory receptors to the central nervous system. So for example, if you were to smell something, the sensory neurons would be sending the message that your nose is getting to your brain so your brain can interpret what is going on, what it's smelling. Then we have the motor neurons. The motor neurons carry outgoing information from the central nervous system to the muscles and the glands. For example, if we are thirsty, our mouth is watering, we want something to eat. Our sensory neurons take that information from our mouth to our brain. Our brain then sends the motor neuron message to our muscles to lift up that glass of water to take a drink. Now the interneurons are kind of the middleman. They are within the brain and the spinal cord, and they communicate internally and process information between the sensory inputs and the motor outputs, or messages from the sensory neurons and the motor neurons. If they communicate within the central nervous system and between incoming and outgoing messages, the neurons within the brain and the spinal cord communicate internally and process information between these two. So they are like the middleman. They send the message where it needs to go. So, let's say that you touch a hot surface or a flame. Your sensory neurons will send the signal to the spinal cord or the brain, and then interneurons then process that information, and then they communicate where to send the next message. The motor neuron will then send the message to the finger or the hand to move. So let's just review what we talked about. So first, the central and the peripheral nervous systems are major divisions of the nervous system. The peripheral nervous system has 2 parts, the somatic and the autonomic. Information travels in the nervous system through 3 types of neurons, the sensory, motor, and interneurons.